Welcome to the second half of section 9.1. In the first half, we talked about simplifying rational expressions. Now, in this part of the section, we're going to actually start to do some operations with two rational expressions. And in 9.1, the two operations we focus on are multiplication and division. We'll get to addition and subtraction in the next section, but for right now, we'll do multiplying and dividing. They're kind of the easier of the four operations, so that's why your book starts with these, kind of an offshoot of what we just did in the first half of the section. Okay, so the first types of problems involve monomials. So we can take a look at this first example, and this is the first example that's in your note sheet. 6c over 5d times 15cd squared over 8a. Now these are monomials because there's no plus or minus operation symbols anywhere in the problem. And for that reason, these are a little bit easier to simplify. We can just cancel out common factors because everything is being multiplied together. So I'll start with the numbers. I see that 15 goes into 5 3 times, so I can rewrite that as 3 over 1. 6 over 8, I can take a factor of 2 out of each of those and make that 3, and then the 8 becomes a 4. And then the letters, I see that there is 1d on both the top and bottom of the two fractions, so I can cancel those out. And that's about it. So all that's left to do is multiply straight across. I'll multiply the numbers, gets me 9. The letters up top get me c squared, because there's a c times another c, d, over 4a, because that d canceled out. Now the only other thing we have to do is we have to give our restrictions. And for multiplication, our restrictions are just going to be the things that would make either denominator of the original problem 0. So in this case, if a were 0, I would have 8 times 0, and that'd be a problem. If d were 0, I'd get 5 times 0, which is also a problem. So those are my two restrictions. So the solution is 9c squared d over 4a, such that a and d cannot equal 0. All right, let's try another one. Okay, this is division. Remember when you divide two fractions, it's really a multiplication problem in disguise. So you rewrite the problem keeping the first fraction the same, changing division into multiplication, and then take the reciprocal or the flip of the right fraction. So now 7a squared b squared goes up top. 24m cubed goes to the bottom. Okay, so we just do the same thing we did in the first example. We'll reduce things. So I see 7 goes into 21, become 1/3. I can take 8s out of the 16 and the 24, and I get 2 and 3. Now my letters, okay, so I have a b squared up top, and I can take out 2 of the b's on the bottom. I can take out 1m on both the top and the bottom, and now this becomes m squared. And, these a squareds will cancel with 2 of the 4a's in the denominator. I think I got everything now. So now I just multiply straight across. I have a 2 for the 2 times 1. And all I see left for the top in terms of letters is a t squared. The bottom, 3 times 3 makes 9. I see an a squared. I see a b. And I see an m squared. And again, I need my restrictions. Now for division. Because we flip this second fraction, nothing in this fraction, both top or bottom, can equal 0. In the first fraction, we only care about the bottom not being 0. So in this case, it looks like that means a, b, and m cannot equal 0, because if any of them will, either the original problem or the flipped problem will have a division by 0 in it. Okay, so we're going to talk more about that when we get to some polynomial examples, but the key is when you're dividing and you're looking for restricted values or excluded values, you got to use the entire right fraction. Both numerator and denominator cannot be 0 because of the flipping that gets done to actually multiply it out. Okay, with that, try a couple of the examples for you to do in the notes, and then we will look at some polynomials. Okay, so here's some examples with polynomials. Now, in this case, we have pluses and minuses in the problem. Like we said when we did one single fraction, you can't just cancel things out that you see similar top and bottom the way we did in the first slide. The first thing we have to do when you have a polynomial, you must factor. Okay, you got to turn this into multiplication in order to cancel out common factors. So what I'm going to do is I'm going to look at anything that's factorable in either fraction and rewrite it that way. So x squared minus 6x minus 16. Okay, that's going to be x minus 8 times x plus 2. X squared minus 16x plus 64. That's going to be x minus 8 times another x minus 8. This is why I've been saying all year factoring is huge. It's back again. Okay, the top one we have an x minus 8, so I'll keep that as it is. I can't factor that any further. But x squared plus 5x plus 6 can be broken into x plus 3 times x plus 2. Okay, and you can check all my factoring by refoiling. Now, I look at common factors, so sets of parentheses that match up. So I see an x plus 2 in the top and the bottom. I see an x minus 8, top and bottom. I see another set of x minus 8s, top and bottom. Notice that first cancellation, I did it all within the same fraction. Students often ask, does it have to be like the top of one fraction with the bottom of the other? Not necessarily. It just has to be a top of the whole problem and a bottom from the whole problem. Okay? So if we look at what's left, everything up top cancels, so I just have a 1. And the bottom, all I see that's left is an x plus 3. So this whole mess multiplies to and reduces to 1 over x plus 3. But then don't forget about our restrictions. We go back to the original problem before we factored, or excuse me, before we canceled, and we check and see what each of these factors, what values of x would make them 0. So for the first one, x minus 8, if x were 8, I'd have a 0, so that means x can't be 8. Well, same thing here, so we don't have to worry about the second factor. We don't have to write 8 twice. Now we go to our third factor, x plus 3. If x were negative 3, I'd have a 0, so I can't make x negative 3. And then the fourth factor, x plus 2, x cannot equal negative 2. So that's your final answer with restrictions or excluded values. Okay? Let's do a division problem. All right, so x squared minus 9x plus 20 over x squared plus 10x plus 21 divided by x squared minus x minus 12 over 6x plus 42. All right, so we can factor, but also remember that we have to really turn this into a multiplication problem and flip to make it 6x plus 42 over x squared minus x minus 12. To save room, I'm just doing that up here so I can just jump right into the factoring. So what multiplies to positive 20 and adds to negative 9? I believe that's going to be negative 5 and negative 4. Okay, the bottom of the first fraction multiplies to 21 and adds to 10, plus 7 and plus 3. Now times, so we'll do the 6x plus 42 up top. Okay, that doesn't look factorable, but never forget about your BFF. There is a GCF in here of 6. So 6 can come out, and I'm replaced with x plus 7. And then the bottom multiplies to negative 12, adds to positive, or excuse me, negative 1. It's going to be x minus 4, x plus 3. All right. So why don't we cancel some things out? I see an x minus 4. I see an x plus 7. And I think that's about it. So we've got 6 times x minus 5 over x plus 3. And I actually have 2 copies of it. So I could write x plus 3 times x plus 3. But since I'm kind of running out of room on my screen here, I'm just going to be sneaky and shortcut it by saying x plus 3 quantity squared. All right, now I need to get my excluded values. So I'm going to check, and I'm going to highlight this so you can see it. I'm going to check all the factors of the bottom of the left fraction and the entire second fraction because of the fact that we flipped in order to actually do the problem. All right, so we'll start with x plus 7 to make that a 0. That means x can't be negative 7. The next factor, x plus 3, means negative 3 won't work. All right, up top, we already dealt with the x plus 7. So we don't have to write negative 7 again. We'll go down to the bottom, x minus 4. All right, that means x cannot equal positive 4. And then same thing, we already dealt with the plus 3, so we're done. By the way, why did I kind of skip the 6? Because this factor doesn't have a variable, so 6 will never be 0 because 6 is 6. All right, you have a couple examples to try in your notes very similar to this. Go ahead and do that. And when you're ready, we'll just have one more that I want you to look at. Okay, so I have one more example using negative ones in our canceling. We talked about this a little bit in the first half of 9-1, and it can show up again in multiplication and division. Okay, so we have 32 minus 4x over 6x plus 18 times x plus 6 over x squared minus 2x minus 48. Okay, as always, when I'm seeing pluses and minuses like this, first step is to try to factor. So 32 and negative 4x, they have a GCF of 4. So why don't I take out a 4, and I'm left with 8 minus x. 6x plus 18, a GCF of 6, and I can take out or leave an x plus 3 inside. Got x plus 6 up top, that's not factorable. And then the bottom, x squared minus 2x minus 48, I want what multiplies to negative 48 and adds to negative 2. So how about I do negative 8 and positive 6? Okay, so if I look and see some pairs, top and bottom, I see the x plus 6's immediately. I can also reduce the 4 and the 6 to be 2 and a 3. Now, notice something. The 8 minus x and the x minus 8. When you have subtraction, okay, and the order is reversed, you can technically still cancel these two factors that I've highlighted. However, in order to get them to be equal, instead of them reducing to a positive 1, they actually reduce to a negative 1. Because if you think about it, if you multiply 8 minus x by negative 1, you get the x minus 8 that's on the bottom. Okay? So to simplify our answer, we look at what's left over on the top. There's the 2 and the negative 1, so I have minus 2 up top. And then the bottom, I see a 3 times the quantity of x plus 3. Notice, and I did this in the last one as well, I didn't distribute anything. I kind of left everything out. That's totally fine. If you wanted to rewrite this as negative 2 over 3x plus 9, that works too. It doesn't really matter to me. You don't have to factor to refoil, if you know what I mean. All right. The only thing we have left to get is our restriction, so it's multiplication. We're only checking the denominators of the originals. Looks like in the left denominator, x cannot be negative 3. The right denominator, x cannot equal 8 or negative 6. Okay, so that's your final answer. All right, I have a few more of these negative 1 examples in your notes. Give those a try. We'll go over all of this in class and do a lot more practice with it for you to get the hang of it. If you have any questions from anything I did in the video, please feel free to ask. And with that, thank you very much for watching.